Today's paper is PVANet, Deep but Lightweight Neural Networks for Real-Time Object Detection. The paper introduces an object detector framework that follows a pipeline composed of CNN feature extraction module, region proposal module, and a ROI classification module. The main idea is in the feature extraction part. It uses less channels with more layers. This is the main idea. And using this idea, the authors make a lightweight feature extraction network that speeds up the performance of the model. The proposed deep and thin network achieves mean average precision of 83.8 on VOC 2007 dataset and 82.5 on VOC 2012 dataset. It also achieves a speed of 750 milliseconds per image on Intel i7 6700 CPU with a single core, and 46 milliseconds per image on NVIDIA Titan X GPU. Now, on this slide, it shows the main idea, which is less channels with more layers. First, concatenated rectified linear unit is applied onto the early stage of the CNN layers. This is also shown in the top figure. Having this module reduces the number of computations by half, but it doesn't lose the accuracy. Also, an Inception module is applied to the remaining feature generation subnetworks to increase the variety of receptive field sizes. This is shown in the second figure, the Inception. Having an Inception module in the rest of the subnetwork effectively captures varying sized objects. Lastly, the idea of multi-scale representation, like in the HyperNet paper, is taken. This, by the authors, say that it combines intermediate outputs to consider multiple levels of details and nonlinearities. Now, here we have a table that shows the detailed architecture of the PVANet. All convolution layers are combined with batch normalization, channel-wise scaling and shifting, and ReLU activation layers. As mentioned earlier, the first conv layers are composed of C-ReLU layers, and the rest of the layers are composed of Inception modules. The detailed Inception blocks can also be observed in the 7th column right here. Also, if we see the rightmost two columns, we see the number of parameters and multiply and add computations as the layers are stacked. The total number of parameters is about 3.3 million. And using this PVANet with other object detection framework improves the inference speed of the model while preserving the accuracy. Now, this table shows the performance of PVANet on Pascal VOC 2012 dataset. As it's described in the table, PVANet Plus is a model with bounding box voting. The model takes 156 by 640 image and makes 200 proposals. The shared CNN's computational cost of the PVANet is, as we can see here in the table, is much lighter when compared to the models with ResNet and VGGNet. The running time is also much faster when making inference on the GPU. PVANet takes 46 milliseconds, while other models take more time. We see that the RFCN model with ResNet 101 backbone takes 133 milliseconds, and the faster RCNN model with the VGG backbone takes 110 milliseconds. Link to the paper and some useful resources will be provided in the description. That's all for today, and I'll see you next time with a new paper.